Myself, Suresh Kumar M, Assistant Professor, Department of Information Science and Engineering, Dayanand Sagar College of Engineering, Bangalore. Today, I am going to present a paper on deep learning techniques for satellite image classification. So, these are the contents I will be presenting regarding this paper: introduction, problem statement, literature survey, proposed work, results, then finally conclusion. First, introduction. Computer vision applications have many uses in many areas, including remote sensing, image retrieval, object recognition, scene analysis and surveillance, image. So that's why it has attracted a lot of attention nowadays. The main objective of this image classification is we should assign class labels, appropriate class labels to every image. And particularly in the domain of remote sensing, image classification plays very crucial role in military applications, civil applications, and many other applications. Coming to the problem statement, what was the conventional method used? So conventional method used mainly they dependent on low level features like colors and texture in the images. But recent advancement shows that we should use CNN, so which have great results in remote sensing as well as other scene classification tasks. So, in effectiveness of deep learning models, my research paper work aims to develop 4 deep learning models by fine tuning existing deep learning models like CNNs, ResNet, Residual Neural Networks, third one VGG19, fourth one Network Mobile Net VT-based models. So mainly I am fine tuning the existing 4 DL models. So here we are classifying the satellite images of RSI CB256 dataset, which is a standard dataset. We are classifying this dataset into 4 classes, namely cloudy, desert, green area, and water. And the main contribution of this paper includes these 3 categories. First category is we are thoroughly examining the deep learning techniques which are used for classifying satellite images or remote sensing images. Second contribution is we are suggesting to provide we are aiming to provide optimized deep learning models for satellite images interpretations. Optimized in the sense best deep learning models for remote sensing interpretations. Finally, we are visualizing training loss and validation loss of different techniques will also be presented. Coming to the literature survey, here we can see one first paper, remote sensing image classification, because that itself is my main topic. So that review and applications has been given by the first paper, which was published in the August 2022 in the Mathematical Problems in Engineering Journal. Main remarks includes earlier approach used in remote sensing was machine learning approaches. Recent trends is deep learning model. That's what I am concentrating now in this paper on the recent trends, that is deep learning models. And future research directions, there will be the hybrid approaches of deep learning. And one more research paper titled Review of Deep Learning Methods for Remote Sensing Satellite Images Classification, Experimental Survey and Comparative Analysis, which was published in Journal of Big Data in the year 2023. The main important remark what they have made is deep learning algorithms can consider complex features of high resolution remote sensing images, which was earlier to handle the complex features it was very difficult, but now complex features of high resolution remote sensing images can be easily handled by deep learning algorithms. Proposed work. So I will be using, as I said earlier, I will be using RSI CB. RSI stands for remote sensing image. CB stands for classification benchmark 256, which is available in the Kaggle website. And this data sets has 4 different classes. mixed from sensors and Google Map snapshot. And the whole dataset has 5,631 images with JPG formats. And dataset consists of mainly four classes, as I said earlier: cloudy class, desert class, green area, and water size. So as we can see, one sample format. Cloudy is image cloudy number of cloudy images are 1,500. Number of desert images includes 1,131 images. Green area images are 1,500. Water images include 1,500 images. So these are the main deep learning algorithms I will be addressing with: CNN based model, ResNet 9 based model, VGG 19 based model, MobileNet V2 based model. So this is a proposed CNN architecture. So input, there are mainly three layers: input layer, output layer, and hidden layer. So as left side we can see input layer, right side we can see output layer, in between we can see the hidden layer. So hidden layer consists of different layers. Hidden layer consists of convolution layers, max pooling layers, and dense layer. So as number of layers also given: three convolution layers, three max pooling layers, and four dense layers. Convolution layers mainly extract features from the input images. Max pooling layers mainly reduce the size and dimensionality of the images. Dense layer mainly predict and classify the input data. So this is the CNN algorithm. So we can find some 8 steps in the CNN algorithm. We are splitting the training data into training and validation sets. In the 80 is to 20 ratios: 80 training set and 20 validation set. And proposed sequential CNN model has 14 layers, as we saw previously. CNN, as I said, CNN uses three different layers: convolution, max pooling, and four dense layers. And finally, we'll be using ReLU and softmax activation functions, and also we are using Adam optimizer in this particular CNN model. And this is a proposed ResNet architecture. So convolution layer, there are number includes 8 numbers, 4 max polling layers, and finally one classifier which is shown in green color. So here also the technique remains the same: convolution used for feature extraction, max pool layers used to reduce size and definitely, classifier to classify the data. And this is a proposed VGG 19 architecture. So convolution layer 16 plus max pooling layers 5. See, the groupings has been done here. Blue color indicates convolution layers, max pooling layers means red color, connected layers or classification layers means green colors. So some groups have been created. 5 groups have been created using the convolution layers and max pooling layers. And finally, there are 3 connected layers which are used for classification. This is proposed MobileNet VT architecture, last 4th architecture. Here we have one global average pooling layer, 2 dense layers. Dense layers are used for classification. And these are the results of CNN based models. So in the first graph, on the x-axis we have epochs from 1 to 20. On the y-axis we have marked train loss and validation loss. The blue color indicates train loss and red color indicates validation loss. What we observe from this diagram is loss is decreased consistently. Both training loss and validation loss has been increased consistently as we increase number of epochs. In the same way, accuracy also increased from 75. Earlier, at the epoch 1, accuracy 75. It increased almost up to 90, nearly 90. So as we increased the number of epochs, so accuracy also increased, loss also decreased. Coming to ResNet 9 second model, here also we observe the loss, validation loss, and training loss decreased consistently when you increase the number of epochs, and also the accuracy increased from 70 to 90 as we increase the number of epochs from 1 to 20. Coming to VGG 19 based model, here also the loss decreased consistently and also accuracy also increased consistently. From accuracy was only 40 at the starting, then it increased up to 90. Okay, so as we increase the number of epochs from 1 to 20. And finally, last model, mobile net V2 based model. Here the loss is not decreased consistently. It is the loss has been decreased inconsistently, we can say, because there are many changes in the there is no consistency in the loss decrease. And in the accuracy also there is no consistency here. See, we can see that starting accuracy is 97 and later the accuracy of finally was also 97. So it is not consistently, accuracy is also not consistently increasing. And these are the accuracy of the proposed models. So we can see here CNN initially accuracy 75, it increased to 90, so accuracy increased. In the ResNet also initially 76, it increased to 92, and in VGG also it was 43, it increased to 91. But in MobileNet V2 initially it was 97, it is 96.83, means there is no consistency increase of accuracy in the case of MobileNet V2 model. The same thing, it has been visualized. Accuracy has been visualized for all the 4 models, and we can see clearly the blue color is the mobile net, so which has highest accuracy, and this is a bar graph depicting accuracy of all 4 models. So CNN models is as accuracy is very low, and mobile net V2 accuracy is high when compared to other 3 models. So I conclude by saying that accuracy of MobileNet V2 based model is highest among all the remaining 3 models. So MobileNet V2 accuracy is 96.83 accuracy, and also it has lower computational cost. That is also important because cost should be less in every cases. So here the computation cost is very less in case of MobileNet V2. That's why MobileNet V2 is preferred over other 3 models for the RSA CB256 dataset. And this MobileNet V2 also has a lightweight architecture with fewer parameters. So parameters also are present are also very less when compared to the other 3 models. On the other hand, CNN ResNet VGG. CNN accuracy is 90.48, ResNet accuracy is 92, and VGG 19 is 91, which are very less when compared to the MobileNet 96.83 accuracy. And all 4 models were trained on epoch count of 20, beyond which there will be overfitting in the all models. In future directions, this work can increase the number of epochs. We can increase number of images in the data set, for example up to 20,000 or 50,000 images for a better analysis of the images. Further, also performance on the satellite images can be enhanced by using larger convolution layers in deeper CNN models. Means the number of convolution layers should be increased to increase the performance or to enhance the performance of the deep learning models. Thank you.